Dear students, today I will discuss a new topic, that is one of the applications of Newton's second law, that is impulse. You might have observed, suppose a cricket ball coming with a very high speed, it strikes the bat and it changes the direction. The speed changes, direction changes. Suppose you are beating a hammer on a nail. Suppose when a body falls from a certain height, when it falls on a cemented floor, you are getting a big jerk. And if you fall on a sand, then jerk is less. So those type of forces, they are called impulsive force. Impulsive force means the force of large magnitude that acts for a very small interval of time. That force is called impulsive force. Once again, the force of large magnitude which acts for a very short time, that is called impulsive force, and the effect is called impulse. The impulse is the effect of a force of large magnitude that acts for a short time to produce a finite change in momentum. That effect is called impulse. And mathematically, it is the product of force and time, and also equal to change in momentum. It is denoted by a symbol J. Impulse J is equal to force into time. It is the product of average force and the time interval for which the force acts. The force may be variable, the force may be constant also, and that is also equal to the change in momentum. Suppose initial velocity is u, final velocity is v. So m into v minus u. You can also write in the vector form. Impulse is a vector quantity. So I can write here in the vector form j equal to f into t, m into v minus u. That is also impulse. And we can show impulse is equal to force into time. That is also equal to change in momentum. You can apply Newton's second law to prove this. And this statement is called impulse momentum theorem. You know, according to Newton's second law, force equal to rate of change of momentum. Force is equal to the rate of change of momentum. Change in momentum divided by time. Change in momentum divided by time. So F is equal to m v minus u by t. So F into t is equal to m v minus u. This is called impulse momentum theorem. What is impulse momentum theorem? The impulse of a force is equal to the product of force and time, that is also equal to change in momentum. Force is equal to rate of change of momentum. Impulse is equal to simply change in momentum. Then what about the SI unit? The SI unit of impulse is same as that of momentum, because it is change in momentum mv minus mu. So what is the unit of momentum? The SI unit will be kg meter per second. That is also equal to Newton second. It is nothing but force into time. Force is expressed in Newton, time is expressed in second. So it is force into time. So Newton second. What about the CGS unit? CGS unit is gram centimeter per second or dyne second. These are the units of momentum and also units of impulse. And the impulse can also be calculated from a graph. That means if you plot a graph between force and time, you see the force applied on a body may be variable, it may be constant also. Suppose a constant force. When a constant force is applied, what is the graph? The graph is like that. Suppose when this is F, force is F, and this is time. When time is T1, force is F. When time is T2, force also F, because it is a constant force. And if you take area under the graph, what is the area? What is the shape of this figure? I can name it. Suppose A, B, C, D. The area of the graph is equal to, it is shape of a rectangle, length into breadth. What is the length? Length is AB. T1, this is T2 minus T1. Here up to this T1, up to this T2. So the interval is T2 minus T1. And this value is F. So the area is equal to force into T2 minus T1. Force into the time interval. That gives you impulse. That means the impulse of a force can be calculated from the area under the force time graph. So area under, remember, the area under force time graph gives you the impulse. It may be a variable force also. The force may change also. Suppose the graph is like this. Force is variable. Now suppose force is increasing. It remains constant, then it is decreasing, becoming 0. So this type of graph is also possible. In that case also, you will find area under the force time graph that gives you impulse. That means mathematically you can find impulse by using the formula force into time also equal to change in momentum. And graphically, if the graph is given between force and time, it may be constant, may be variable. In both the cases, area under the force time graph gives you the impulse. Now, I will discuss some examples for better understanding of the concept of impulse. Now, I told you the formula. Impulse J equal to F into T, that is equal to M V minus U. That means for the same change in momentum, if you increase the value of force, then time decreases. If you increase the time, then force will be more. If you decrease the time, force will be more. If you increase the time, force will be less. That means impulse equal to product of force and time. That is equal to change in momentum. Let us discuss one number of examples. You might have seen when a cricketer catching a ball lowers his hands downward direction. A cricketer lowers his hands while catching a ball. You might have seen in the cricket match. Why he is lowering the hands? When he is lowering the hands, suppose a ball is coming with a certain velocity, and when he is catching the ball, it will come to rest. So that is a large change in momentum. A large force, it is coming with a very high speed, it is coming to rest. And if suddenly he catches the ball, then it will come to rest, but force will be large because time interval is small. When he lowers the hands this way, he increases the time interval so that the impact of force decreases. This is one example. Another example, suppose you are in your long jump or high jump, either you are jumping on sand or in cushion. If you jump on a hard floor, what will happen? You will get more injuries if you are jumping on a cemented floor or hard floor. Why this is so? When you are jumping on sand or a cushion, it yields. Yields means it takes more time before coming to rest. But when you jump on a hard floor, a cemented floor, suddenly it is coming to rest. So that time interval is small. So impact of force is large. So that's why we are jumping on sand. Similarly, suppose a glass is dropped from a certain height on a hard floor and a sand. Same condition. On a hard floor, time of contact is small, so impact of force is large, so it will break. Similarly, the glass materials and chinawares, they are packed in straw or thermocol. Why this is? When they are packed in straw or thermocol, when a jerk is there on the road, when we are transporting, what will happen? The time interval will increase when they collide with the walls, so that the impact of force will be less. Similarly, buffers are provided in trains. When compartments are joined, some lubricants are provided. They are called the buffers. And in your vehicles, you might have seen suckers are provided, shock absorbers. So shock absorbers or suckers are provided to reduce the impact of force in the place of jerk and all. So these are some of the applications of impulse. Now let us solve a small numerical based on impulse. Suppose a cricketer hits a ball in the same direction. Suppose now a ball is coming with a speed of 5 meters per second. Strikes the bat and it hits the ball, the cricketer hits the ball in the same direction with the same speed, 5 meters per second. The question is, what is the impulse imparted to the ball? And impulse is equal to, force into time or change in momentum. Suppose mass of the ball is 150 gram or 0.15 kg. And find out J is equal to M V minus U, and mass given to you 0.15 kg. V, final velocity. U is the initial velocity. Final velocity 5, initial velocity also 5. But when it is coming, if you take velocity, initial velocity is plus 5, final velocity will take minus 5 because it is going in opposite direction. So minus 5 minus 5. So it is minus 10. So this will be 1.5. That means minus 1.5 kg meter per second or Newton second. This is how you can calculate the impulse imparted to the ball. Once again, as the ball is coming with speed, velocity 5 meter per second, this is initial velocity U. When it returns back, the velocity is minus 5. So just put the values, minus 5, minus 5, minus 10. So minus 1.5 kg meter per second or Newton second.